It might sound like an oxymoron to have a black hole jet. If you know black holes eat everything that comes near them, how can it have a jet? That would be a jet of energy and gas and other materials. So I thought I might spend a minute offering an understanding of the anatomy of the vicinity of a black hole. So a couple of things. If you have a black hole and something's going to fall into it, that can happen. But if it's going to fall straight in, it's got to exactly line up with its position in space for it to fall straight in. Most things that are wandering by are not headed straight to the center of the black hole. They're coming off to the side. Well, it'll feel the gravity of the black hole. Its trajectory will be altered. Yes. For it to get to the middle of the black hole, it needs to lose that orbital energy somehow. And thus is the beginnings of what we call an accretion disk. You have a black hole and there's material coming by. The black hole pulls it in and it swirls. And it slowly then feeds the black hole, feeds the monster. As this material slowly loses energy, it gets closer and closer and closer to the black hole, then ultimately gets pulled straight in. Well, all of the material that's coming near a black hole participates in this. Big black holes can have big accretion disks. Where are the biggest black holes in the known universe? In the centers of galaxies, where they have a mass equivalent to hundreds of thousands or millions of times the mass of the sun. These are singularly large black holes in the universe, in the centers of galaxies. And we're still debating how they get made. Are they there from the beginning in the formation of the galaxy? Did they occur later? What feeds them? Okay. As long as you're feeding a black hole, it's going to have an accretion disk. And that accretion disk will get hotter and hotter and hotter. Why does it get hotter? Because the orbital energy has to go somewhere. So it goes into heating the gas of this spiraling disk. It gets so hot, it radiates not only in the red or the infrared or not only white hot or blue hot, it is so hot, it radiates X-rays. Oh my gosh, that's highly energetic. Okay, now, how does the energy get out? Which way does it go? It's not going to exit through the accretion disk because the accretion disk is in the way. How's it going to get out? Oh, wait a minute. If it's a disk and I'm energy and I want to get out and I can't get out through the disk, I want to get out above and below. So when we look at the anatomy of black holes, we find accretion disks and plumes of energy spewing forth above and below the black hole itself. And we call these jets. They're jets of matter and energy mixed together. Energy as in photons, very high temperature matter, ejected from the system because it has to get out somehow. There are only two directions left, the North Pole and the South Pole of this accretion disk.